Okay, in this video we're going to review how to add and subtract variables in MATLAB and all the kind of little subtleties and intricacies associated with that. Okay, and so we know that variables in a computer program, they represent often the value of some kind of numerical entry, whether that be a scalar, a vector, or a matrix. Variables can be used for other things too, but most commonly we use them to represent numbers, okay, just arranged in a different way. And just like we do by hand, we can use code to add or subtract variables together. We can perform basic arithmetic, right? And so in this example here, I've defined two variables, variable 1, variable 2, and I'm adding their results, and then I get their sum, which is 9, right? And so very simple. And so if you have variables that represent numbers, you add them together just like you would on paper. Okay? But we can also use the add and subtract operators in MATLAB to add variables that represent vectors and matrices, okay? And so when this happens, we do vector addition or matrix addition in very much the same way that you understand it from by hand calculations, right? And so if you have two vectors, you have two matrices, you add them together. When you do that, you add their corresponding entries, right? And so you can see for this vector example here, we add the first entries together, we get 9. The second entries together, we get 11. Third entries together, we get 13. Okay. And then for these 2 by 2 matrices, we're adding the corresponding entries. And if you're unfamiliar with this kind of notation for defining matrices, I'm using commas here to separate different entries on the same row. And whenever you see a semicolon, that basically means to go to the next row, right? And so this syntax here, 1, 2, semicolon, 3, 4, is a 2 by 2 matrix where 1 and 2 are on the first row, and then 3 and 4 are on the second row. Okay. And then since here we're performing a subtraction, we're doing a subtraction of the top left entries, 1 minus 6, then 2 minus 7s in the top right, 3 minus 8, 4 minus 9, and we get minus 5s all around. Okay. So one error that you'll find commonly when you're doing this matrix vector arithmetic is matrix dimensions must agree. Okay, and so what this means is that you're trying to add together two vectors or two matrices that don't have the same dimensions, or their sizes are not the same. Okay, and so in this example here, we are trying to add together two vectors of different lengths, and so one has a length of 2, the other has a length of 3. Okay. And when you try to subtract them together, MATLAB gives you an error because it doesn't know what to do, because you can't add or subtract together vectors of different lengths. Same thing with these matrices here. And so here I'm trying to add together a 2 by 3 and a 3 by 2. This leads to an error. And so whenever you see this error, it's probably happening because you're trying to do arithmetic on variables that don't have compatible dimensions. Okay, so there are some special cases, and so if you try to add together a row and a column vector, meaning a row vector is one that's completely horizontal and a column vector is one that's completely vertical, something special happens. And so you actually end up with a matrix whose size is determined by the size of the two vectors. Okay, and so in this case we have a row vector with size 2. That means our result has 2 columns, and our column vector has 3 rows, and so our result's going to have 3 rows. Okay. And each entry here is going to be the element by element sum of the constituent vectors. Okay, and so since this row vector is 10, right, that means on this first column here we're going to add 10 to everything. Second column we're going to add 100 to everything, and then we add 1s, 2s, 3s along the different rows. Okay, so this isn't used often. I'd say this is fairly niche, but it's good to know kind of what's happening here. But you can actually add a scalar value to a vector or matrix. And so what happens then is that scalar value, arithmetic, is applied to every entry in the vector or matrix. Okay? And so in this case, we have a vector whose length is 3. And if we add 9 to it, then what's going to happen is going to add 9 to every single entry. So 6 plus 9, 7 plus 9, 8 plus 9. Same thing with this matrix, right? So 1 plus 9, 2 plus 9, 3 plus 9, 4 plus 9. And the results should reflect that. Okay, so this is kind of a nice shortcut if you want to add something to every single entry in a matrix. Okay, and so the last thing I want to go over here is what happens when you add a vector to a matrix when their sizes are compatible. So this is also a fairly niche functionality or feature, but we should go over it just for completeness. And so if you have a vector whose length is the same, matches the dimension of a particular matrix, what you can do is you can add them together, and then that row and then that vector entry is added to each of the corresponding entries in the direction perpendicular. Okay, so that's kind of a word soup, but what that basically means that if you have a 3-column row vector, right? So a length of 3, and you add it to a matrix which also has 3 columns, then what's going to happen is that each entry of the vector is going to be added to the corresponding column, right? So 1 is going to be added to everything in this column right here. That's why we get 11 and 101. 2 is going to be added to every entry in the second column. That's why we get 22 and 202, and then so on for the last one, right? And so this is, again, fairly niche. I don't think you'll be using this very often, but if you do run into a case like this is what's happening underneath the hood.